we're asking you, oh, and this is just the last problem. This is the solution to the last problem, just kind of working through. They found the radius by using the distance formula, and then they went through and plugged it into the equation. And so you had your standard form of the equation. So you can pause it and copy it down. It's the same as what was on the previous page, but I just thought you probably would like to see that. So moving along. This time we have a point which is centered at 0, 0 or the point on 3, 4, which is on the circle, and the circle whose center is 1, 4. Write the standard form of the equation. Now I don't want to graph it. You can graph it if you want, and you can do what you can use Pythagorean theorem, but this is where the distance formula comes in handy, because now I now have these 2 points, and I'm just going to use the distance formula to find the radius. I have an h, I have a k. If I remember my equation, my standard form equation for a circle, it's x minus h squared plus y minus k squared equals radius squared. So plugging in my h and k, I can start my equation. So I'm going to go over here and say x minus 1 squared plus y minus 4 squared. That will equal my radius squared. Problem is, I don't know my radius. And the only way I can find my radius is finding the distance between these 2 points. So that's what I'm going to do. I'm going to set up my distance formula, and I'm actually going to call it r because I really want the radius. So setting up my distance, that is, remember you subtract your x's. So subtracting my x's in my distance formula, I'm going to go with the bigger one. It doesn't matter what order you subtract x's in or y's in for the distance formula, because the squaring and square root will take care of it. So 3 minus 1, I'm going to go with positives. So I end up with positive numbers because I like positives better. And then 4 minus 4. And so a little simplification, r comes out to be the square root of 2 squared plus 0 squared. So r then is the square root of 4, so r is 2. Well, if I square 2, that's 4. That's where this number comes from right here, because this would have been r squared equaled 4, and then they took the square root of both sides. So my final answer is x minus 1 squared plus 4y minus 4 equals 4. And you can see that in this, again, my center is opposite. -1 is really +1, and -4 is really +4. That's my center, and square root of this number is the radius that I found. So moving along, this time, same thing. So go ahead and pause it and give it a shot. I am going to do this one right away, real quick. So I know the center, so using my standard form, x minus h squared plus y minus k squared equals r squared. So I know my h is 2, my k is 6, so I plug those in. So I get x minus 2 squared plus y minus 6 squared equals, well, radius squared. That's the thing I got to find. And so that's what I don't know. So again, I have to use my distance formula between these 2 points. And so r, I'm going to go with r equals the square root of, well, subtract my x's, and I like the positive, so I'm going to start with a big number, minus -1 squared, plus, now subtracting my y's, 6 minus 2 squared. And again, I chose whatever numbers went first, bigger numbers first, so I try to get positives. Well, what happens when I subtract a -1? That's really adding, so I really have 3 squared, and 6 minus 2 is 4 squared. So underneath my square root, it looks like I get 9 plus 16. And so that means square root of r is 25, so r is now 5. So rewriting my equation over here, final answer for this one is going to be x minus 2 squared plus y minus 6 squared equals 25. Because I'm squaring, I need r squared, not just r, and so I square the 5, which gives me 25. Again, look at my center. -2 here is really +2 for the center. -6 is +6, and square root of 25 is my radius, which is what I was looking for. So now I'm giving you a circle and this time and an equation, and I want to know well, I'd want you to graph this. And I don't know why the graph is showing up here. That's okay. Well, the graph is actually the solution to the problem. And so basically what I'm going to do, I'll walk you through this, is I need to find my center. And remember, the center is the opposite of what you see. So I see that this is, so my h value, my center is my h value, which is the opposite of -4, which is +4. My k value is the opposite of +2, which is -2. And that gives me this point right there. And then my radius is the square root of 36, which means radius is 6. So from the center, you'll see each square is 2. If I go up 2, up 6, 2, 4, 6, there's point, over 6, 2, 4, 6, back a point, 2, 4, 6, and down a point, 2, 4, 6. If this graph wasn't drawn here, I would draw these 4 points, and then I'm going to draw a circle around, connect those points. My circles very rarely look like circles when I actually have to draw them. They end up looking like footballs a lot of the time. So this time they're doing the same thing, and so we just need to go through and find our center and find the radius of our circle. So pause it, try it on your own. This time I'm going to find my center. Remember, it's opposite of what I see. H is opposite of what I see. K is opposite of what I see. So that means I'm at +4 and -3 for my HK, my center. And my radius then is the square root of 16, which is 4. So now, if I was going to sketch this, and I'm gonna actually sketch this out. I'm not gonna look at the answer over here. I'm gonna sketch it out. And so, oops, that would be nice if that was a straight line, but I'm gonna sketch it out. And by sketching it out, let's see, to get to my center, I got to go to the right 4, 1, 2, 3, 4. So there's point, and down 3, 1, 2, 3. So there's now my center of my circle. So from that point, I'm going to count up 4, down 4, left 4, right 4. I'm going to count 4 in every direction. So if I count back 4, that would be this point right there. If I count up 4, I'm going to be 1 above the x-axis. If I count to the right 4, I got to add on 4 more. 1, 2, 3, 4. I end up over here. And then if I count down 4, 1, 2, 3, 4. And part of my problem is that, oops, that these guys aren't all, I'm not very good on spacing. So now I'm going to try to connect, and again, like I said before, my circles always kind of end up looking kind of weird. And so, but that is the circle, and that's what we've got over here. So down right 4, down 3, and then a radius of 4, and I just counted that out. And so you can see my circles are similar, even though my circle is very lopsided. At this point, most people usually laugh at how I drew my circle. So moving along on to the next problem, again, I have to find my center. I always start with, I have to sketch my graph, I have to find the center, and it's the opposite of what you see. So it looks like I'm at -8 and -5. That would be my center, the opposite of what I'm seeing. And if I take the square root of 121, that's my radius. Well, the square root of 121 is 11. So now I have my center and my radius. And so I plot the point, I count 8 over, count back 8. That's what they did. They counted back. They're counting by 3s, 3, 6, and then over 2 more would be 8, and then 3, 6 would be all the way down there, so they're back. They're just, because the 11 is so big is why they counted. But if I was doing this, I would sketch it out, count out all the spaces, and you'll be fine. Your circle will just be bigger. It's okay. And so that's what your graph should look like. Your radius of 11, if you count the squares that they've got 11 in there. And so that's how you're doing this. All right, so then we're on our out, and this is a page from the book, and it's just a matter of, it's just asking you for the equation of a circle. And so the equation of the circle, I believe, is x minus h squared plus y minus k squared equals r squared. And so that's what I want for the out for this. And so we'll talk more about this in class. I hope you guys enjoy this webinar. I will talk to you guys soon.